Hello everybody, this is a demonstration phase of the RC Walker Basic algorithm A and B. These two programs have a goal of showing you how to apply the Send Think Act paradigm to the basic remote control of a walking mini. In the book I have more detail of all the steps, but here just a summary. So we have the Send Think Act paradigm, which is a loop from the world to sensors to robot and actuators. And a computer is just really just a model of the interaction in the real world. So therefore, this loop you're going to see is reproduced inside the robot computer. And in order to create a robot control program anyway, we had to concentrate to this area, which as far as the robot is concerned, it just monitors certain events, and then when some event happens, and then it does some appropriate action. And when you follow this approach, it's called reactive control or event programming. You're going to find out that basically if you can create a list of event, like for example, the initial event, it happened only one time at t equals 0, what kind of initialization action should you do? And then there's an endless loop that will take care of this loop. Is you just have a list. Event A, you do some action A until event Z to have some action Z. So reproduce it in the example code in this for this demonstration. So first you see that you call init, and then you have the endless loop here. But there are two ways to do about it, algorithm A and algorithm B. They both have endless loop, but within it, if your first action is to check on the motion status, your status is false, that means if the robot is not moving, and then you go in and check on whether some kind of remote controller data coming in and save into data in, and then you process it. Whether it's up, down, left, right, you move the robot accordingly. In algorithm B, the first action is to check for the remote data arrived. So you check that first, and then if it's arrived, you pick it up, get it in, and if it's nothing, that means you didn't or release a button, and then it goes in and it goes to initial position, basically just standing still in the ready position. But you can see that the if-else structure is still here, up, down, left, right. But now you have an extra case for when you release a button. When you use this approach, though, you have to remember that you have to use a wait while as long as status is moving. So it's one way or the other. So I'm going to pull in the actual robot, and I put in the remote controller. And let's see how it works. So in this example here, I'm using the version where every time you push, it does the motion 3 times and then stop. The previous one was version A, so this is the version B here. But overall, you can really tell there isn't any difference.